So, as I ask each of you, I'm going to ask each of you, what was your role in the construction of your device? Okay, so we can start with you. You want to tell me what role you played?
Well, I kind of helped out on trying to put the tube where the ball is going to be rolling down.
Okay, and what's the benefit of that to your machine?
Because it actually gives like a little, like a push in order for the ball to have more pull from the gravity in order to fall into the bucket.
Okay. All right. What did you contribute?
Well, a lot of stuff that wasn't included, but
okay,
it led to this. But then I started to focus with Thomas and trying to make this work properly.
Okay.
Just like with the force of gravity, like help it.
Okay. All right. Thomas, you want
to? My baby is the suspended weight. That hopefully by just pushing it over the threshold there'll be enough force to dispense the shaving cream.
Okay.
I had the idea to put all of these things, to stack things, and then I rubber band them all together to the same place. And I made this other contraption that we thought was going to work, and then ended up not working.
Didn't end up working.
Yeah.
Okay. All right. So some of you have already said what ideas you had that weren't incorporated. So, do each of you feel like your ideas were valued? Yes?
Yeah.
Y'all worked together really well?
I think we all tried something that didn't work.
Yeah.
So in the end, we've done something that worked.
That's how things generally happen. Most things don't work, and then you figure it out. All right. So tell me what's gonna. One of you can just tell me, or in pieces, tell me how this machine is going to work and what it's going to do.
Well, I'm gonna drop the ball to this tube, and then it's gonna come down and hit the chair. The ball's gonna fall into the bucket, and it's gonna pull down on the weight that's going to make the shaving cream come out.
Okay, so again, the physics of this, we start at the beginning. There's a tube that's angled so that it can convert potential kinetic energy into kinetic energy. The gravity creates the potential energy at the top. So as gravity pulls the ball down the tube, it accelerates. So that acceleration is a step. It's then going to leave the tube and hit the chair. There's a collision there. Now, an interesting example here, it's not really pushing the chair. It's the chair pushing back on the ball. So it's the reaction pair that you're using in this case, and you are using the equal and opposite reaction of the chair pushing on the ball to knock the ball into the bucket, which is just enough weight to pull on the strings that are attached to these vices, to pull down on them enough to actually push on the top of the canister. Now, there's a couple hidden steps here. The canister itself has compressed gas under pressure. And so what you're doing is releasing that pressure and allowing that pressure to push the foam out of the tube. So actually there's a couple steps, again, hidden in that canister. And I always like to point these kinds of things out because even though they aren't part of your design, the physics involved in how do you keep something like that foam from leaving the canister until you're ready is an engineer's job. All right, so let's see it work. Oh, I think I could get a shave out of that much shaving cream. All right, you want to try one more time? Got to get it into the bucket. There you go. All right, very good.